Hello, in this video I'm going to talk about basic atomic structure. In order to talk about atoms, we first have to talk about matter and elements. So matter is anything that has mass and occupies space, like a table or even air. All of those things have mass and occupy space. Matter is made up of elements, and elements are things that can't be broken down into smaller pieces by any ordinary means. You've probably seen a periodic table that shows all the different elements that exist on Earth. So elements include things like iron and magnesium and potassium and carbon. The term chemical or substance or mixture or molecule or compound, these are all somewhat general words that refer to elements or combinations of elements. An atom is the smallest quantity of an element that retains the properties of that element still. And atoms have certain characteristics, and these are determined by the structure or the makeup of that atom. So let's take a look at what actually makes up an atom. So you've probably heard of atoms before, and you probably know that they're made of protons, neutrons, and electrons. So we call these subatomic particles. We're going to pretend these are the smallest things in an atom, but in reality, there are smaller pieces that make up things like protons and neutrons. So we have protons, neutrons, and electrons. The protons and the neutrons are located in the center of the atom called the nucleus. The electrons are located outside of the nucleus in areas that we're going to refer to as electron shells. In this picture here, we can see that our atom has a nucleus. The yellow structures are protons. The red ones are neutrons, and those are located in that center part, that nucleus. And then the electrons, represented by the blue circles, are located outside of the nucleus. So let's talk about these subatomic particles in a little bit more detail. Protons are positively charged, and they do carry a mass. They have a mass of 1 Dalton, which is sort of like a really small gram or pound, if you will. 1 Dalton is also equal to 1 atomic mass unit, in case you've heard that term before. The amount of protons in an atom is really important because it determines which element that atom belongs to. So it turns out that every single carbon atom out there always has 6 protons. Every nitrogen atom always has 7 protons. Now, the numbers of electrons and neutrons within these atoms can differ, but the number of protons is what determines the element. The proton number also determines a property of the atom called the atomic number. We'll talk more about this in a little bit. Electrons are negatively charged particles, so they're kind of like the opposite of a proton. But unlike a proton, they have no weight to them, they have no mass. We say their mass is negligible. And electrons are really where all the fun is in an atom, because electrons are what allows atoms to interact with each other, forming larger structures. Like 2 hydrogen atoms and an oxygen atom can interact via their electrons to form water. Neutrons do have mass to them, like a proton, but they do not carry any charge. Neutral neutron. Like a proton, they weigh 1 Dalton. And now we know how to kind of come up with the atomic mass of an atom, because we know protons have mass and we know neutrons have mass. And if we know the numbers of protons and if we know the numbers of neutrons, we just add that up to get the atomic mass of an element. So this is a periodic table of elements. You've probably seen this before. It lists all the known elements and it gives us information about those elements. So in this periodic table, we see elemental symbols like C for carbon, atomic number like 6 for carbon, and the average atomic mass of all the known versions of carbon, which is 12.011 Daltons, or atomic mass units. And this table also gives us the element name. So let's talk a little bit more about atomic number. So atomic number is the number of protons in an atom for an element. So down below, I have a little cutout from the periodic table. See if you can figure out how many protons oxygen has. If you said 8, you're correct. The number 8 above the O gives us the atomic number, which is the number of protons. How about sulfur? What's the atomic number for sulfur? Well, the 16 above the S gives us the atomic number, and maybe we'll also took this one step further and decided there were 16 protons in sulfur, and you would be correct. So now let's look at atomic mass in more detail. Again, we have a little cutout of the periodic table over here, right? We can see that carbon has an atomic mass of 12.011, right? Using that little periodic table, see if you can determine the atomic masses of potassium and magnesium. So if you said potassium was 39.098 and magnesium was 24.305, you're correct. So the atomic mass is the mass of all of the protons plus all of the neutrons in that atom. Because one proton weighs 1 Dalton and because one neutron weighs 1 Dalton, if we just know the numbers of protons and neutrons, then we know the atomic mass. The atomic mass of a single atom is equal to the numbers of protons plus the numbers of neutrons. Now you might have noticed that the periodic table has atomic masses with decimal points on that. How is that possible? Well, we can talk about the atomic mass of a single particular atom, which is just adding up the numbers of protons and neutrons, or we can talk about the average atomic mass of all the known versions of that particular element. And that's the atomic mass that we see on the periodic table, and that's why there's a decimal point there, because there's lots of different versions of that element out there. When talking about atomic mass, I think it's important to talk about a concept called isotopes. Isotopes are different versions of the same element. They're all the same element because they all have the same numbers of protons. But what's different about them is their numbers of neutrons. And because protons and neutrons determine the atomic mass, these different isotopes have different atomic masses. Let's take a look at some examples. So down below, I have 3 different pictures of carbon. They're all carbon because they all have 6 protons, and anything with 6 protons has to be carbon. But these are all different isotopes of carbon. They're different isotopes because each of these different versions of carbon has a different number of neutrons. The first one has 6 neutrons, the middle one has 7 neutrons, and then the one on the right has 8 neutrons. So these are all carbon, but they all are different isotopes of carbon. Now, because the atomic mass is determined by the numbers of protons plus neutrons, each of these different isotopes has a different atomic mass. Now let's take a look at electrons in a little bit more detail. We've kind of talked about determining the numbers of protons and neutrons in an atom, but we haven't looked at the numbers of electrons. So how do we know the numbers of electrons in an atom? Well, the number of protons is equal to the number of electrons if the atom is neutral, meaning uncharged. Why is that? Well, let's take a look at an example. Let's say we have an atom with 4 protons and 4 electrons. Each proton has a positive charge, so we have 4 positive charges in this hypothetical atom, and each electron has a negative charge. So if we have 4 electrons, we have 4 negative charges. Each positive charge will cancel out each negative charge, leaving this atom with no charge, or leaving it neutral. So we're going to assume atoms are neutral, but charged atoms are called ions, and they do exist, and they are really important for physiology, and we'll talk a lot about these more later. But let's assume atoms are neutral, and assuming they're neutral, see if you can fill in the blanks below with the correct numbers of electrons. So if carbon has 6 protons and the number of protons equals the number of electrons, it must have 6 electrons. Likewise, if sodium has 11 protons, then it must have 11 electrons if it is neutral. So let's review all of these subatomic particle concepts that we've talked about. Right? Don't forget the atomic number is equal to the number of protons. The atomic mass is equal to the number of protons plus the number of neutrons. And the number of electrons is equal to the number of protons, assuming the atom is neutral. So what I'd like you to do is to pause the video and complete this table by filling in the blanks. So I want you to calculate the table amounts below. Don't use a periodic table to look up the information. I want you to calculate the missing information here. And then we'll take a look at the answers. All right, so we were given the number of protons and neutrons for oxygen, but we had to determine the number of electrons. The number of electrons is easy. It's just the same as the number of protons. Okay, so it had to be 8. The atomic mass is a little bit more complicated. The atomic mass is equal to the number of protons, 8, plus the number of neutrons, 8, giving us 16. For hydrogen, we were only given one piece of information, the atomic mass, right? But we can get all the other information based on that. Don't forget, protons determine the base of an atom. So if the atomic mass is 1, there had to be 1 proton. The tricky thing here is that there were 0 neutrons, because we know the atomic mass is equal to the number of protons plus neutrons. So if there's 1 proton, there had to be 0 neutrons. And of course, the number of electrons is equal to protons. So 1 proton means there will be 1 electron. And then for chlorine, we were given the numbers of protons and the atomic mass. So the atomic mass gives us the number of protons plus neutrons. So 36 minus the number of protons, 17, will give us the number of neutrons, 19. And of course, the number of electrons has to equal the number of protons, so it had to be 17. A little bit more on electrons before we go. So electrons are located outside of the nucleus in areas called shells. And we have a certain number of shells for each atom, and each shell can hold a certain number of electrons. So the first shell is the shell that's closest to the nucleus, and the first shell can hold 2 electrons. The second shell is second closest to the nucleus, and it can hold 8 electrons. The third shell is third closest to the nucleus, and it can also hold 8 electrons. In this class, we rarely go beyond the third shell, so we're not really going to look at that. I also wanted to mention that we have a special name for the outermost shell of an atom. This is called the valence shell. So the electrons in the valence shell are really important because these are the electrons that are going to be able to cause atoms to interact with other atoms, allowing us to form larger structures. Now, we were assuming that atoms were neutral, but I want to talk about the case of when we have an atom that's not neutral. I want to talk about ions. So ions are charged atoms, and a charged atom can either have a positive charge or a negative charge. And to determine if something is an ion, we really have to compare the numbers of protons to the numbers of electrons. Okay? So if there are more protons than electrons, the atom will be positive. We call that a cation. Cations are positive. You got it? Cats have paws. And then if an atom has more electrons than protons and it has more negativeness than positiveness, we call that an anion. And the term ion is applicable to not only just atoms, but larger groups of atoms too. So what I'd like you to do is take a look at the atomic model that's at the top of the page here, right? So I'm going to give you some information about it, but then I'd like you to answer the questions that are to the side of it. So this atom has 11 protons and 12 neutrons. That information is given to us in the nucleus. The green dots are representing electrons, and we can see that this atom has 9 electrons. So go ahead and pause the video and see if you can answer the questions to the side of this atom. So the first one might have thrown you off a little bit. What element is this? How do we figure this out? The information is not here on the page. That's where we would turn to a periodic table. So how do we even determine the element based on the information given? Well, we really have to answer the second question first. What's the atomic number? Don't forget the atomic number is equal to the number of protons. So there's 11 protons, so we go to the periodic table and we see that element number 11 is sodium. Right? What's the atomic mass of this atom? Right? Well, to determine the atomic mass of an atom, we have to add up the number of protons plus the number of neutrons. So 11 plus 12 will give us an atomic mass of 23 daltons. Is this atom neutral, a cation, or an anion? Right? Well, again, we're no longer assuming neutrality here, so let's determine whether or not it is neutral. How do we do that? We have to compare the numbers of protons to electrons. We know there's 11 protons, right? And then we can count up the green dots to determine that there are 9 electrons. So we have an imbalance of protons and electrons here. We have 2 more protons than electrons. Protons have positive charge, so we have 2 more positive charges than we do negative charges. So this particular atom has a +2 charge, right? Does that make it a cation or an anion? Cations are positive, and this is an atom that has a +2 charge, so this would be a cation.